In today's video, we're going to do a brief introduction to two topics that are very important in algebra, but we do want to touch on them before we move on from our functions unit. The first thing we're going to talk about are continuous versus discrete functions. So the first thing we're going to talk about is a discrete function. And a discrete function is where you have separate, distinct points. And it is not possible to connect these points on a graph with a continuous line. So you're looking at a bunch of plotted points. So something like that's your coordinate grid, a bunch of points, that would be a discrete function. A continuous function is every point in the domain can be interpreted. And it is possible for a continuous function to connect the points on the graph with a continuous line. So something like this would be a continuous function. They're connected together. All right, so some examples. So we have to decide whether each situation describes a continuous or discrete function. So number one, the number of siblings you have. Since we can't have 2.5 siblings or 1.5 siblings or 1.25 siblings, this is going to be a discrete data or a discrete function. You may have one brother or sister, you may have no brothers or sisters, you may have 3 brothers and sisters, so nothing in between. The time it takes you to read a book. This is going to be a continuous function because in order to finish a book, you have to read for 1 second, 1 minute, 1.5 minutes, 10 minutes, 12 minutes, so you're catching every single data point in between when you start and when you finish. You can't skip from 1 second to 10 minutes. There's no discrete point. So you're continuously reading from start to finish. The distance to grandma's house, this is also continuous. Because as you're driving, you can't skip from mile 5 to mile 60. You have to drive all the miles in between, including the partial miles. You'll have to drive 10.5 miles, 12.75 miles, 13 2/3 miles in order to get from home mile 0 to grandma's house, wherever that is. The amount of the amount of pencils that Ms. Drexel has for borrowing during class. This is discrete. I may have 0 pencils to borrow, I may have 1 pencil to borrow, I may have 5 pencils to borrow, but I don't have 1.5 pencils to borrow. And for those of you who like to think outside the box here, just because a pencil is sharpened halfway down doesn't make it half a pencil. You either have something to write with or you don't. So that's a discrete data point. The speed of a race car is going to be continuous. Okay, a continuous function because your car has to start at 0 when you're starting racing, and then it speeds all the way up to whatever your maximum speed is, 100 miles an hour. But in the process, it hits every single speed along the way. Again, you can't go from 0 to 100 in no time. There has to be a little bit of time for acceleration. The volume of your ice cream cone, this one's kind of tricky. If you're thinking about the number of scoops, that would probably be a discrete function. So you would have 1 scoop, 2 scoops, 3 scoops, 4 scoops. But if you're talking about the volume of the amount of ice cream that you have, this is going to be a continuous function because you could have 1.5 cubic centimeters, you could have 50 cubic centimeters. It's all, you can have every single data point along the way. The age of your mom or your dad or sibling or brother, we typically tend to measure age as a discrete function. We tend to measure, if somebody says, how old are you? You would say, I am 13 years old or I am 12 years old. You don't typically say anything like, I am 12.127985, whatever years old. You usually give a discrete number. Sometimes you might include halves, but that would still be a discrete. So sometimes you might say, I'm 13.5 or I'm 12.5. But again, you're not really, you're estimating between a whole number and a half, so you have discrete points. The weight of your dog, this is typically a discrete function as well. If you think about reporting the weight or somebody's weight, or the weight of a dog, I weigh 25 pounds, or the dog weighs 25 pounds, 25.5 pounds. At some point, you're just estimating a weight, you're rounding it off. Again, there's an argument for that is continuous as well, and I would be open to discussion about that, but for the most part, weight is going to be a discrete measurement. We just measure in pounds, usually round to the nearest pound. Your height, probably discrete as well. Again, I am open to discussion on these, but if you think about reporting of heights, most people say, oh, I am 8.5 feet tall. Well, probably not 8.5. I'm 5.5 feet tall. You don't really report, I am 5.6 feet tall. It's pretty much a discrete point. And the area of your house's floor plan, that one could probably also be discrete as well. You have a certain number of square feet in your house, and typically you report that as a whole number. It's not something that's reported as a decimal or a fraction. But again, a lot of these are open for interpretation, so if you would like to have a discussion about them in class, just let me know and we can talk about them. All right, the second topic that we want to talk about today is slope, and this is again just a very basic introduction to slope. Slope is also known as the rate of change, and it's the ratio of rise, or the vertical change, to run, which is the horizontal change, between any 2 points on a line. So we're looking at how much do you go up or down compared to how much do you go from side to side. So the formula for slope is rise over run, or the change in x, so we call it the change in delta, the change in, so the change in y over the change in x. So delta means change in. So the change in y over the change in x. How much do you go up and down over how much do you go side to side? A straight line slanted upwards from left to right, so it looks like this, slanting upwards from left to right, has a positive slope. A line slanted downwards from left to right has a negative slope. A horizontal line has a 0 slope, and a vertical line has an undefined slope. So if you think about a vertical line, you can't climb up or down it. It's vertical. So we call that undefined. Okay, examples. State whether each slope is positive, negative, 0, or undefined. Then find each slope. Okay, so if I look at example 1 right here, I notice my line is sloped downwards from left to right. So I can think about maybe somebody walking downhill. And that means it's going to be a negative slope. Okay? And if I look at my 2 points here, I look at my vertical change, I went down 1, and then my horizontal change, I went to the right 2. So my slope would be negative 1 over 2, down 1 over 2. All right, example number 2, if I think about having a person on this one walking from left to right, I'm climbing uphill, so that's going to be a positive slope. And if I look at my 2 points here, there's 1 here and 1 here. I have a vertical change of 1, 2, 3, 4 over a horizontal change of 1, 2, 3, 4, 5. So my slope would be 4/5. Here I have a vertical line. You can't climb up a vertical line. So I would call that undefined. Okay, and then a horizontal line is completely flat, so that's going to be a 0 slope. All right, last example, the graph below shows the distance of a sprinter, shows the distance a sprinter is from the starting line as a function of time. Which runner is running the fastest, A or B, and why? So if I look at time here and the distance they've traveled, the answer would be runner A, because runner A has covered more distance in the same amount of time. So one more time, runner A has run further. Here's your time. Runner A has gone a further distance in the same amount of time than runner B.